Hello people, what I'm about to discuss with you is the single most important message in the whole world in 2024. This is not some bullshit from a snake oil salesman. I have nothing whatsoever to gain. This is based on real science with documented evidence that cannot, and I repeat, cannot be disputed. In fact, the professor welcomes anyone to dispute his team's findings. Now see this. What is this? That is the number of cancer patients that have died so far this year. And that is at this date, which is the 5th of January. The 5th of January, and already 126,169 people, 170, have died in the world somewhere. You hear about all the successes. It's all bullshit. Absolute bullshit. You know it, and I know it. Yes, there are some cancer survivors. I'm one of them. But most of them are beat up from the conventional treatments with the chemo and the radiation that have got not much of a life after that anyway. I had a tumour removed from my backside, the size of an apple. It's left me urinating and defecating in a bag for the rest of my life. Yes, I'm still here, I hear you say, but as you're about to discover, it doesn't have to be that way. So now, let's take a look at a recent interview with, I'll have to read his name, Dr. Regan Chatterjee on his channel with Professor Seyfried.
Heard prominent oncologists in the UK, Professor, say things like, we are born with the genetic codes for cancer within our cells, but they're kept locked in place by suppressor genes. And then something happens, whether it be from carcinogens in the diet or the environment or whatever we're exposed to. And then what happens is that genetic material becomes rearranged. And once it becomes rearranged, those cells no longer stop growing and they become cancerous and they spread. So that's a viewpoint I've heard. What is your view on that? And I guess more broadly, where did genes fit into this whole conversation around cancer?
Yeah, well, of course, that's the basis for the somatic mutation theory here in the United States. National Cancer Institute, on their website, they say cancer is a genetic disease caused by mutations in specific genes, tumor suppressor genes and proto-oncogenes and these kinds of things. And this leads to a dysregulated cell growth. And this is the dominant consistent view we have right now, the somatic mutation theory, where the mutations arise randomly in a population of cells, which then leads to disorder of the cell cycle and the proliferation. But you have two different kinds of genes. You have those inherited in the germline, and you have those that are acquired through various insults in the environment. When you mentioned about BRCA1, that's a inherited mutation that contributes to a greater risk for breast cancer. And when you look at what does the BRCA1 mutation do, it disrupts oxidative phosphorylation in the mitochondria. The most prominent inherited mutation is the P53 mutation in the Li-Fraumeni disorder syndrome, the Li-Fraumeni, where about 80%, you have about 80 to 85% penetrance of that gene, leading to ovarian cancer, breast cancer, brain cancers, a variety of cancers that are linked to the Li-Fraumeni. The Li-Fraumeni encodes a protein in the electron transport chain of the mitochondria, cytochrome C oxidase 2. So what these inherited mutations are doing, and we went through all of the inherited mutations, and all of the inherited mutations, risk factors, damage mitochondria in a particular way, putting them on the path to destabilized energy metabolism and a consequent fermentation metabolism. So the inherited mutations are what we call secondary risk factors, not primary risk factors, because in order for an inherited mutation to be a primary cause of a disease like the presenilin mutation in Alzheimer's disease, that's 100% associated with the development of Alzheimer's disease. There is no cancer gene-linked, a germline-linked mutation that is 100% associated with the onset of a particular cancer. So we call those secondary risk factors, just like being exposed to a carcinogen. If you inherit a mutation in BRCA1 or one of these, your risk for the development of cancer is certainly higher, but it's not 100%. Now, in somatic mutations, this is where this is where a cell in the body will randomly accumulate mutations, some of which will then lead to destabilized growth. Okay. So where do the somatic mutations come from? And they come from destabilized energy metabolism in the mitochondria. How does that happen? So ROS, reactive oxygen species, are a byproduct of dysfunctional oxidative phosphorylation. So the oxygen that the tumor cell is taking in is not being used efficiently for ATP synthesis, but rather is throwing out these radicals, these reactive oxygen species. What do? They cause mutations in the DNA. They lead to the mutations in the DNA. So the mutations that we see in cancer are largely downstream epiphenomenon of the damage to oxidative phosphorylation, forcing the cell into a fermentation metabolism, leading to acidification of the microenvironment, which further damages the nuclear genome. So that most of what we see in cancer, the genetic mutations, are largely downstream epiphenomena of the damage to oxidative phosphorylation. So they're not effects, they're not causes, they're effects of this whole process.
Okay.
So, did you get that? No, really. Did you really get that? I bet you didn't. This is going to absolutely blow you away. The whole flipping cancer industry is wrong. Did you see Reagan's face there? The damage to the genes are not the cause of the disease. They are downstream effects of damage to the mitochondria. We've been searching in the wrong place all this time. Is it any surprise that we've had minimal, or in fact garbage, results in treating cancer? Let's just have a look at that again.
Downstream epiphenomenon of the damage to oxidative phosphorylation, forcing the cell into a fermentation metabolism, leading to acidification of the microenvironment, which further damages the nuclear genome. So that most of what we see in cancer, the genetic mutations, are largely downstream epiphenomena of the damage to oxidative phosphorylation. So they're not effects, they're not causes, they're effects of this whole process.
That'll do it for today. Thanks for tuning in. Please like and subscribe. You can find me on X at Vincent Gledhill. And until next time, bye-bye.